Hi dear students, this is Wajid Ali Shah and today we are going to explain the topic Maxwell's equation which is given on page number 219 of class 2nd year physics book. Dear students, first of all let me tell you that what actually Maxwell's equations are. Maxwell, during a research, he found that all the basic principles of the electromagnetism can be formulated in terms of the four fundamental equations. And those equations are called Maxwell's equation. Maxwell is the name of a scientist who basically united and comprehended the equations already formulated and experimented so many times into a single set of equations, and that single set of equations is called Maxwell's equation. These equations are existing as Gauss's law, Faraday's law, and Ampere's law. For simplicity, here for this grade 12, we are going to explain mathematically those equations and what actually and how they laid the foundation for electromagnetism or electromagnetic waves. First part of the topic given in the book is changing magnetic field produces an electric field. And this is, I think, the law given by Michael Faraday in 1831. And from that law, Maxwell's basically laid the foundation of electromagnetic waves. Like the first part of the topic is changing magnetic field produces electric field, and derivation is as under, like this. As we know from Faraday's law of electromagnetic induction that EMF is equal to delta phi divided by delta T, EMF electric field concept, and this is magnetic flux, where phi or magnetic flux is equal to B dot A. Putting this value of the phi BA here in this equation, we can have EMF is equal to delta over delta T into BA. We can put the value of phi BA, magnetic flux. Dear students, we know that EMF is due to the electric field. It means that when a magnetic field is changing across a loop, across a circular conducting path, so EMF is because of the electric field, so it means that electric field will be generated at every point of the loop. So electric field is generated at all the points of the loop. EMF is there, electric current should be there. And this is happening because of the changing magnetic flux across the loop. So, if a net positive charge is circulating along the loop, for example, a net positive charge is circulating along the loop because of the changing magnetic field, so the total work done on that charge can be calculated like W is equal to Fs, where S is basically the displacement of the charge starting from one point and coming back to the same point. So the circumference of the circle should be given as a displacement, so F is in its own place, and instead of the displacement 2 pi r, so simply 2 pi r F is the work done on that charge by the changing magnetic field producing EMF E. Again, from the previous knowledge that EMF or the potential difference is equal to work done per unit test charge, putting the value of W 2 pi r F divided by Q. Again, we have from chapter number 1 that F is equal to QE, so 2 pi r F, instead of F we can put the value QE divided by Q. So these two Q's are cancelled with each other, and 2 pi RE is the total EMF induced in this loop by the changing magnetic field. So, dear students, we also know from Faraday's law that EMF is equal to delta phi divided by delta T. Comparing this equation 1 and equation 2, we can have that this is equation 1, 2 pi RE. This is equal to EMF, again from Faraday's law, delta phi over delta T. This is again from Faraday's law, so they are same things. It means right side of the equations are also similar and having the same concept and same value. So comparison of equation number 1 and 2 gives us the idea that 2 pi RE is equal to delta phi B into A. Instead of phi, we can put the value of the magnetic flux. So E is equal to A divided by 2 pi r. We can divide both sides by 2 pi r. So 2 pi r cancelled here, and we can also have E is equal to A divided by 2 pi r or delta V divided by delta T. As we know that area of the loop 2 pi r, they are constant, so we can say that the induction or the production of electric field depends upon the changing magnetic field. So this is the first result, that a changing magnetic field produces electric field. That's the first equation, the first result of the Maxwell, taken from Faraday's law of electromagnetic induction. Dear students, another result of the Maxwell taken from another equation we can have, like the changing electric field produces changing magnetic field. Changing electric field produces changing magnetic field. This is another result of the one of the equations given by scientists and comprehended, explained by the Maxwell. As we know that for a capacitor Q is equal to CV, we can put the value of the capacitance, like in previous chapter number 1. We had already proved that capacitance of the capacitor is equal to epsilon naught A divided by D, and V is in its own place. So we can put the value of C, capacitance, like this one here in this equation, and equation becomes like this one. Okay, again from the same chapter number 1, we have an idea that electric field intensity in the topic potential gradient, like V over D, is equal to electric field intensity E. So we can have Q is we can have from this equation, we can have Q is equal to epsilon naught A E, epsilon naught A, and instead of V divided by D, we have put the value E. Also we know that the current is equal to delta Q divided by delta T. What is actually the current? The flow of the charges per unit time is called current. Actually, we are going to find a relation between magnetic field and electric field. So, current is equal to rate of change of the charge. So, delta Q divided by delta T. We can put the value of Q from this equation here, and it becomes delta epsilon naught A E divided by delta T. So, I is equal to epsilon naught into A. They can be taken out as they are constant, and delta does not apply on these two. So we can write epsilon naught A delta E divided by delta T, where Ampere's law gives us the concept of magnetic field produced by the current, electromagnetism. The magnetic field produced by the current, so B is equal to mu naught I divided by 2 pi R. And we can find the value of I from this equation, having I is equal to B 2 pi R divided by mu naught. Putting value of this current I in this equation, we can have B 2 pi R divided by mu naught is equal to epsilon naught A delta E divided by delta T. So 2 pi R divided by mu naught, they are constant, they can be taken on the right side of the equation, and B is equation becomes like B is equal to mu naught epsilon naught A 2 pi R delta E divided by delta T. So as these values are constant, so we can show that the magnetic field is directly proportional to rate of change of the electric field. It means the changing magnetic field is produced by the changing electric field. This is another result of the Maxwell equation, and we have a third result of the Maxwell equation, which is basically a proof of the speed of light. So third point of the same topic is light is also a type of the electromagnetic wave. By different calculations, we can find the speed of light, like is given by, we can prove the equation like C is equal to 1 over mu naught epsilon naught under the root, where epsilon naught is equal to 8.85 into 10 raised to power minus 12 Newton meter square per coulomb square, and mu naught, which is called the permeability of the free space, that is equal to 4 pi exponent minus 7 Weber per ampere per meter. We can put these two values, they are constant values, we must remember these two values. If we put these two values in above equation, so putting these values in the above equation, we can calculate the speed of light as c is equal to 3 into 10 raised to power 8 meter per second, which is the experimental value of the speed of light, and it is a result of the Maxwell's equation. Thank you. Have a nice day.